Hello everyone. In this video, we are going to execute task 1 prediction using unsupervised machine learning. The problem statement here is for the given iris dataset, we have to predict the optimum number of clusters and represent it visually. The language used here is Python and the Jupyter notebook is the IDE. Now there are some steps to be followed when we are designing an k-means algorithm. Some of the steps here followed are: Step 1. Importing our dataset and visualizing and analyzing the dataset. Step 3. Design the k-means clustering algorithm for optimal clusters. Plot the k-means clustering graph and identify the optimum number of clusters from the graph. Step 5. Visualize the clusters. Step 6. Make prediction. And finally in the step 7. Evaluate our model. Step 1. Step 1. Importing our dataset. Here we are going to use iris dataset which I have already imported using sklearn. Then here I have created a data frame which includes the values of the iris dataset as well as the columns. See, after displaying our dataset, we can see this. In the columns there are sepal length, sepal width, petal length and petal width and some rows. Using iris df.head, we can print the top 5 values of our dataset. And using iris df.shape, we can find the dimensions of our dataset. Like here we have 150 rows and 4 columns. Next, in iris.irisdf.describe, which displays the numerical insights in the datasets such as the total count of the sepal length, sepal width, petal length and petal width, and mean of it, and standard deviation, and some more numerical insights. Finally, checking the null values in our dataset. Luckily, we don't have any null values. If there are null values, we should replace or ignore the rows which contain the null values. Step 2. Visualize and analyze the dataset. Initially, we are finding the correlation between our data, such as what is the correlation between the sepal length and sepal width, petal length and petal width, and petal length and sepal width, and so on. I have already plotted an heat map of our iris dataset. You can see it here. Next, I have also plotted an pair plot for our iris dataset. In this pair plot, mainly it considers the two attributes at a time, such as sepal. See here, you can see sepal length and petal width and petal length. The two attributes are considered at once. Step 3. Initially, I have extracted the values of all the different attributes into the variable x and printed it. Next, now I am defining the k-means clustering algorithm. As we don't know the optimal number of clusters, the way to do this is to use the follow. I have kept the I in the range from 1 to 10. As we don't use very large number of clusters, I use this small range. Now I would be storing the value of each iteration in WSS, which stands for within cluster sum of squares. And by using these values, we will plot the k-means clustering graph. So you can see that here. By using this, we'll identify the optimal number of clusters from the graph. For this, we'll use the elbow method to find the optimal number of clusters. From the elbow method graphical representation, we can see the optimal number of clusters where the elbow occurs. See, you can see there, this is an elbow. Then within the WCC, it doesn't decrease significantly with each iteration. Therefore, from the graph, we can choose here from the elbow that the optimal number of clusters is 3. Then we will be applying k-means to the dataset or creating the k-means classifier with optimal clusters to be 3. Then we would be pivoting the model to perform the predictions. Step 5. Visualize the clusters. We will be visualizing the clusters on the first 2 columns. And here I am plotting a scatter plot for our clusters. Here the red indicates the iris setosa, blue indicates the iris versicolor, and green represents iris virginica, and yellow color represents centroids. Step 6. Making predictions. Here we are defining our input and target variables. Here X contains the sepal length and sepal width, Y contains the target species value. And here I have printed our X values in an array and similarly Y values, and then visualizing our X and Y variables in graphical form. Here these two values represent the sepal length and sepal width respectively, and C stands for the target variables which we are concentrating on. And then I have plotted another scatter plot which is sepal width versus sepal length. Step 7. Evaluating our model, comparing actual versus predicted values. Before doing that, we will create a new labels for our data which basically tells us which cluster the given data point belongs to. See, you can see the array. Here is our new label. And then finally, we are going to plot our actual versus predicted values. See, it's quite similar and more efficient as our actual clusters are very similar to the predicted values. And this is the k-means clustering. Thank you.